Okay, the purpose of this video is to explain how to solve quadratic inequalities in one variable. In the previous video, we had both x and y in the inequality, and so we graphed it on an xy plane. So we have a number line to represent the x and a number line to represent the y. Here, in these examples, they're only in one variable, so all we have is an x. So when we go to graph our solution step, instead of putting it on the xy plane, we're going to put it on a number line that represents the x's, and I'll show you how this works. So the 4 steps that are at the top of your notes are the following. You're going to replace the inequality with an equation. You're going to find the real zeros of that equation and then place those on a number line. Then you're going to test numbers from each interval of the number line in the inequality, and then you're going to write your answer. So I'm going to walk you through 2 examples, and the 2 examples I'm going to walk you through here are number 2 from the sheet and number 4 from the sheet. All right, so the first thing we're going to do here is we're going to take this inequality that we've got, and we're going to replace it with an equation. And the reason for that is because we're interested in figuring out where it's less than or equal to, and in order to sort of get that figured, we need to figure out where it's equal to first. And I'll explain that a little bit more as we get farther along. So I'm going to find the real zeros of this equation. Now I could do this in any number of ways. I could complete the square, I could use quadratic formula, I could factor. I happen to look at this and know that I can solve this by factoring. So I'm going to move everything over to the same side, and I'd like 2 numbers that multiply to give me negative 14 and to give me negative 5. So that'd be negative 7 and 2. And I can drop these directly in parentheses because the coefficient on the x squared is just 1. I can use the zero product property and say x minus 7 has to equal 0, so x is 7, and x plus 2 has to equal 0, so x is negative 2. So these are my real zeros on my equation. So now we're at step 2 still. We're going to place those numbers on a number line that represents the x's, and we're going to put them in order, so negative 2 is smaller than 7. So we have 2 numbers here, and those 2 numbers divide the number line up into 3 parts, 3 intervals. So if you look at step 3, it says test numbers from each of the intervals of the number line in the inequality. So I'm going to take a number from this interval where it's less than negative 2, a number from between negative 2 and 7, and a number that's bigger than 7, and test them all in the inequality. So a number that's smaller than negative 2 is negative 3. So I'm going to start by testing negative 3. And by testing it means I'm plugging it in to see if it makes the inequality work. So I'll plug it in the original inequality. So negative 3 squared is 9. Negative 5 times negative 3 is plus 15. And so 9 plus 15 is 24. 24 is definitely not less than or equal to 14. So the interval we just chose that number from is kind of like doing a test point. You do a test point and then shade where the point works, and if it doesn't work, you don't shade there. Same thing here. So I'm going to write no above this. That indicates that it does not work in that interval. So now I'm going to pick a number between negative 2 and 7, and an easy number to do there would be 0. So when I plug in 0 this time, 0 squared minus 5 times 0 is less than or equal to 14. That tells me that 0 is less than or equal to 14, and that is definitely true. So that means the interval it came from actually works in the inequality. And then I'm going to test a number that's bigger than 7. So let's try 8. 8 squared minus 5 times 8 less than or equal to 14. So that'd be 64 minus 40 less than or equal to 14. 24 less than or equal to 14, definitely not true. So this doesn't work. So now we know the numbers that work, and that's those numbers between negative 2 and 7. So I could write the answer in inequality form, or I can write it in interval notation. I kind of like interval notation. So I would say x is in the interval between negative 2 and 7. And then the way to know whether or not you include the numbers is to look at the original inequality. If there was an equal sign here, you include the endpoints. If there was not one, you do not. So I'm going to include both of these because I had an equal sign there at the beginning. All right, so let's look at this second example. So the first thing I would need to do is to replace the inequality with an equation, so I'll do that. I'm going to find the real zeros of this equation and place them on a number line. So this one doesn't look like it's going to factor, so I'm just going to jump right in and do quadratic formula. x equals negative b plus or minus the square root of b squared. So negative 1 squared would be 1 minus 4 times 2 times 10 all over 2a, which would be 4. So let's see, that would be 1 plus or minus the square root of 1 minus 80, which is negative 79 over 4. Okay, so right here, you can see that we're going to get something that is imaginary, and normally that's okay. But when we're doing these number lines, the number lines that we draw are real number lines. There's no place to put these imaginary numbers on that number line. So whenever you get something that's imaginary in one of these quadratic inequalities, when you're doing this number line like method, then you put no numbers on the number line, because this is a real number line. There's no place to put the imaginary numbers. Now, a lot of people are like, does that mean there's no solution automatically? Does that mean the thing doesn't work? No, what that really means is, like in example 1, when you place those numbers on the number line, it divided the number line up into 3 parts. All this means is, if I have no number to place on the number line, the entire number line is one part. So it's either all gonna work or it's all not gonna work. So the answer is gonna be either all real solutions, all real numbers, or it's gonna be no solution. So the way you figure that out is you pick any number and test it. Your test point could be anything. So I'm gonna choose 0 because that's the easiest thing. And if I plug 0 in, I get 10 is greater than or equal to 0. That is true, so that means the interval in which that falls works. So that means the entire number line works, so x is all real numbers. If that had not worked, your answer would be no solution. You should be able to do the other 2 problems on the sheet now.